Hey scientists! Today you are going to be learning about thermodynamics, specific heat capacity, and heat vaporization. My name is Alnatan Rical Hermo from Grade 10 of FECA, and let's get started. So yesterday, when I was cooking my standard egg sandwich breakfast, a thought occurred to me. What if it was possible to actually burn paper without destroying it? So I searched it up on Google. How to burn paper without destroying it? Then Gemini said, you can actually burn paper just with water, alcohol, and salt. So you might be wondering, how is any of this possible? Here's the explanation. Thermodynamics is the branch of physics that studies the relationship between heat, work, and energy transfer within a system. Essentially, it dictates that energy cannot be created or destroyed. It can only be transferred from one form to another, such as converting the chemical energy stored in alcohol into thermal energy or heat during combustion. In our experiment, we leverage these principles by using the specific heat capacity of water to absorb the thermal energy and its latent heat of vaporization to undergo a phase change, aka steaming, thereby acting as a thermal shield that keeps the temperature of the paper below its ignition point or burning point. With this information, I present to you the cold fire experiment. Please be advised that if you replicate this at home, proceed with caution and proper guidance. Thank you. Hello everyone, this is the actual experimentation. You can see our apparatus here. This is the alcohol, water, and salt solution. So this was the aftermath of so you can see it burned, but it stopped. You can see it's damped. So that's the main purpose of salt and alcohol. A cold fire means that it stops once it reaches a certain degree. Although it burns for 2 seconds, it later on dissolves and then stops burning. That is the purpose of this experiment. As you can see, it was a success. And yeah. What were my findings? Based on my experiment, I observed two distinct outcomes that define the limitations of this demonstration. Firstly, the ideal result occurred when the alcohol to water ratio was perfectly balanced, meaning the thermal equilibrium was perfectly balanced. The alcohol burned off in a bright orange flame, thanks to the sodium emission, while the water absorbed the heat, leaving the paper intact but damp.